Next example. Prove that the lines x minus 2 upon 1 is equal to y minus 4 upon 4 is equal to z minus 6 upon 7 and x plus 1 upon 3 equal to y plus 3 upon 5 is equal to z plus 5 upon 7 are coplanar. Also find the equation of the plane containing these two lines. So in this example, equations of two lines are given and equations are in Cartesian form. Here we have not to verify, but we have to prove that lines are coplanar. For that, condition of coplanarity is there, determinant equal to 0. And after that, we have to find equation of plane containing these two lines. Now from equation of each line, we get coordinates of one point and direction ratios of line. Numbers in denominator, they represent direction ratios. Numbers in numerator, they are coordinates of point on that line. As two lines are there, for first line coordinates of point we shall denote by x1, y1, z1. So x1 2, y1 4, z1 6. Here all the three coordinates, they are positive. And as point has three coordinates, it is point in space. Direction ratios for first line we shall denote by a1, b1, c1. So here a1 equal to 1, b1 equal to 4, c1 equal to 7. For second line, coordinates of point x2 minus 1, y2 minus 3, z2 minus 5. For second line, we are getting a point for which all the three coordinates are negative. Direction ratios a2 3, b2 5, c2 7. Then condition of coplanarity of two lines in Cartesian form. Determinant equal to 0. Before using that, for convenience, let us find difference between corresponding coordinates. x2 minus x1, minus 1 minus 2, minus 3. y2 minus y1, minus 3 minus 4, minus 6. z2 minus z1, minus 5 minus 6, minus 11. Two lines, they are coplanar if determinant equal to 0. In determinant, x2 minus x1, y2 minus y1, z2 minus z1. Second row, a1, b1, c1. Third row, a2, b2, c2 equal to, put the corresponding values, minus 3, minus 7, minus 11. Second row, 1, 4, 7. Third row, 3, 5, 7. Evaluate determinant. Minus 3 into bracket 28 minus 35 minus 7 minus minus plus 7. Second element of first row with opposite sign. Here negative sign is there. Here we have to take positive sign. 7 minus 21 minus 40 minus 11 into bracket 5 minus 12 minus 7 minus 3 into minus 7. Multiplication of two negative numbers positive. Here one number positive, another negative. Product negative. 14 sevens are 9. Plus 11 sevens are 77. 7 plus 1, 8. 7 plus 2, 9. 98 minus 98, 0. For the two lines, condition of coplanarity gets satisfied. It means that given two lines are coplanar. This is one condition. After lines are coplanar, we have to find equation of plane which contains both these lines. Indeterminate. X minus x1, y minus y1, z minus z1. Second row, a1, b1, c1. Third row, a2, b2, c2. And this is equal to 0. Instead of x minus x1, y minus y1, z minus z1, in first row we can write x minus x2, y minus y2, z minus z2 also. Remaining two rows remain same. It means that we have to take either coordinates of point on the first line or coordinates of point on the second line. Whichever line we select, we have to take all the coordinates from that line only. Don't take x1, y2 like that. Either x1, y1, z1 or x2, y2, z. Put the corresponding values. Indeterminate. X minus x1 is 2, y minus y1 4, z minus z1 is 6. Next two rows same as this. 1 4 7 3 5 7 is equal to 0. Evaluate determinant. X minus 2 into 28 minus 35 minus 7 minus in bracket y minus 4. Second element of first row with opposite sign. 7 minus 21 minus 40 plus z minus 6 into bracket 5 minus 12 minus 7 equal to 0. Now simplify equation. Minus 7x, open the bracket, plus 14 minus minus plus 14y minus 56 minus 7z minus minus plus 42 equal to 0. Rearrange the terms. First we shall write terms containing x, y, z. Minus 7x plus 14y minus 7z. Collect the numbers. 42 plus 14, 56 minus 56. Get cancelled. For convenience, we may divide by 7 or minus 7. If we divide by minus 7, then coefficient of x will become positive. Sign of each term will change. X minus 2y plus z. 0 by minus 7. 0 upon any non-zero real number is 0. And this is a required plane which is passing through given two lines. Observe equation of plane. Generally, equation of plane in Cartesian form, ax plus by plus cz plus d equal to 0. But in the equation of plane, constant term is absent. It means that plane is passing through origin. Find the distance of the point with position vector I plus 2j minus k from the plane. R bar dot in bracket I minus 2j plus 4k equal to 10. Position vector of one point is given, equation of plane is given. Equation of plane, it is in vector form, and we have to find distance between point and plane. We have to find distance between them, means minimum distance, that is perpendicular distance. Now position vector of point, suppose it is point A with position vector A bar. Equation of plane, it is of the form R bar dot n bar equal to D. In bracket we get vector which is perpendicular normal to the plane. Usually normal vector denoted by n bar. I minus 2j plus 4. Value of D 10. This is point A with position vector A bar. Draw perpendicular from point A to the plane. Suppose it cuts at point M. So we have to find A. And here n bar, it is a vector which is perpendicular normal to the plane. Now distance between point and plane, perpendicular distance, it is given by the formula mod A bar dot n bar minus D divided by magnitude of n. D is known to us. We have to find magnitude of n bar. We have to find dot product of A bar with n bar. Dot product of two vectors is a scalar quantity. A bar and n bar, they are expressed in terms of unit vectors I, j, k. So they are dot product, sum of product of coefficients of I, j, k. Product of coefficients of R, 1 into 1, 1. Plus product of coefficients of J, 2 into minus 2, negative, minus 4. Product of coefficients of K, minus 4. 1 minus 8 minus 7. Find magnitude of normal vector n bar. N bar in terms of ijk. Magnitude of vector is given by square root of sum of squares of the scalars. Coefficient of I 1, coefficient of j negative minus 2, coefficient of k 4. So 1 minus 2 4, they are the scalar quantities. Square them. Find their sum and put that under radical sign. 1 plus 4, 5 plus 16. So 21 under radical sign. Now put the corresponding values here. A bar dot n bar minus 7 minus value of d 17 divided by magnitude of n bar root 20 mod minus 17 by root 21. Mod of negative number is positive, 17 by root 20. This is distance or length. It is expressed in units. So when we know position vector of any one point and equation of plane in vector form, we can find distance between point and plane using this formula. Next example. Find the equations of planes parallel to plane. X minus 2y plus 2z minus 4 equal to 0, which is at a unit distance from the point one, 2, 3. Equation of plane in Cartesian form is given, and we have to find equations of planes which are parallel to given plane. In which form we have to find equation of plane, it is not given. But given equation of plane, it is in Cartesian form. So we shall find required equations of planes also in Cartesian form. In equation of plane, coefficients of x, y, z, they are the direction ratios of normal to the plane. When planes are parallel, direction ratios are proportional. So coefficients of x, y, z we may take same. What we have to change is constant. Parallel to given plane. So we can take direction ratios either proportional or same. So we shall take terms of x, y, z same. Constant term, suppose p. So here p is unknown. We have to find its value. And distance of plane from given point is unit distance, means distance equal to 1. Now we can find distance between plane and point if equation of plane Cartesian form, coordinates of point x1, y1, z1. Then distance between plane and point is given by mod ax1 plus by1 plus cz1 plus d divided by under root a square plus b square plus c square. A, B, C, D we get as coefficients from equation of plane. x1, y1, z1 coordinates of point. A 1, x1 1. B coefficient of y, it is negative, y1 2, C z1 2 and 2 z1 3. D from equation of plane P equal to under root a square plus b square plus c square, 1 square plus minus 2 square plus 2 square, and it is equal to 1 unit distance. In the equation there is only one unknown p. So by solving this equation we get values of p. Here mod sign is there. To eliminate mod sign we have to take plus or minus sign on right hand side. Due to that we get two values of p. After getting values of p, put those values in equation 1. As there are two values of p, we get such two equations of required planes.
Welcome to Sanjeevani Education Group. Sanjeevani Education Group is a IIT NEET coaching hub which is renowned for producing the rankers in different competitive exams from national level 11th and 12th JEE NEET, Standard 10 NTSC MTSC, 6th and 9 Dr. Homi Bhabha Bal Vaidyanik exam, 5th and 8th scholarship exam, 7th Olympiads along with IIT NEET Foundation for all classes. We have experienced faculty who focus on the academic development of students. So dear parents, hurry up. For admission, visit Sanjeevani Education Group, plot number 13, Aditya Nagar, Gadkhera, Aurangabad, or call 95112 70135 or 95112 66680.